So, was it difficult to explain the physics associated with LIGO and gravitational waves to the royal family?
Did you hear his question? Yeah. He asked how hard it was to explain. Is this mic working?
Well, it says
Yours is working, right?
it doesn't. Okay, so you want me to repeat louder? Okay. The question was, how difficult was it to explain the physics? The physics of LIGO and gravitational waves to the royal family.
Oh my. You got the question now. I didn't meet them very much. I mean, I'll tell you what my biggest fear was. And I've not answered the question by answering a different thing. That's the big And the way I'll tell you, the thing that was very funny and complicated was that, when you have this, I mean, I've never been to one of these. I never had ambitions to be in a place like that, but it happened to be I was there. Okay. And so what happens was that the king was a little bit older than, well, he's probably a little older than I am, or maybe just about. And I thought he was maybe a little bit dottery, okay? And so I was worried that he was going to hand me this fairly heavy, manuscript thing that has a plaque as well as a gold thing, okay? And I felt, no, that's not way enough. So I was figuring I was walking toward him, and I was the oldest. I don't know if you know this, but physics is the prize that has the highest cachet. So physicists always go first. And the oldest physicist goes first. So that's the result. And I'm the oldest. I'm 85. So what happens, I had to be the first to go into to talk to at the ceremony. And I was very worried. What I was deeply worried about is that I might just pick the thing wrong and we would drop the damn thing. And then we both would sort of going down like this and have our tuchus hanging out, looking at the audience. And it would be kind of embarrassing to screw the whole thing up like that. And so I kept worrying, how do I grab it so that he doesn't fall and I don't screw it up. Okay, we managed that. And so that was the thing that was occupying my walk towards. So we didn't have a conversation. That's the first thing. Then on the way back, I had a sort of complicated thought, and it turns out Kip Thorne had the same thought. He says, what in hell am I doing here? Walking that same thing a family did? It's crazy. I don't belong in that group. That's completely nuts. And this whole thing of, my God, who has walked all that path before? And that left both of us in the end sort of awestruck. Okay, we have no business here. That was it. So that's that. So we never really had a conversation with the king.
Okay. Okay. Well, for us, imposter syndrome, exactly. And as far as we are concerned, you deserve that place more than many.
Well, all right, leave it go. But I mean, that's what you asked. What was going on? That was the conversation that I had with myself.
Okay. So now a little more difficult question. Given that you pioneered, what we can do is just hold it.
Okay. I hold it. You hold it.
Given this brand new field that you pioneered, what do you foresee for the next 10, 30, and 100 years into the future? This is recorded, so people will compare notes.
Well, I'm supposed to say a little about that in this talk this afternoon later. I hope I say the same thing here as I do there. But it's very clear there's a new field that's opened. I mean, I think even the NSF understands that now. It isn't just the detection of gravitational waves and it's over. I mean, I was very deeply worried about that all that technology and all that stuff would be looked at as a one-shot deal. An experiment, and the experiment worked. So now, a lot of people have been looking at this, what might be the next big things that come out. And of course, we had a banner year last year, which was completely wild. I mean, we'll talk a little about that this afternoon. I mean, that neutron star binary, and then the fact that Virgo was on the air with us and we were able to locate the black holes better. That's sort of the beginning of a whole thing that's now going to happen. I said to my colleagues when I walked in, after all these two events in 1 week, I said, oh, God damn it, we're going to see a supernova tonight, right? Okay. And that's why, that's another thing that's, of course, much advertised and hopefully we will see sometime. But then the thing is, you start looking at what new things can be done, and especially the people who are looking at what new detectors are worth building, at least from our side. And it looks like you can do some spectacular things looking at the whole universe in black holes. I mean, it needs a somewhat better detector than now, if you want to look at the whole universe. But that's going to be a fantastic thing on its own. You're going to have not only doing cosmology, but you're going to find out when did they come from, where they come from. I mean, you guys must have been thinking about that a lot now. I mean, that's a deep problem. We don't, and we'll say more about that later. I have no wisdom on that. But you, at some point, maybe you'll find out it ends. There are no more black holes, and that would be wonderful to find out. Or you might find out it doesn't end. I mean, I rather doubt that. But so that's one thing. And then I still hope that there will be something we can see in the cosmic background. I mean, I know the B modes, I wish them luck. I really hope they succeed with this. But if there's something there, it would be wonderful if you could see it. Now, that may not be possible with the detectors now. I don't know, unless it's really very much larger than people thought. But I think it's the most spectacular source that you could look for. I mean, you know, I don't know. All of us have been thinking about that. And then there's all sorts of things which, the Kip, if you ask Kip this question, I'll answer for Kip. Because I've talked many, many years with Kip about this. And here is a standard Kip answer, okay? It's a wise answer, but it doesn't answer it completely, okay? And what it is he says, look at all the things that have happened in electromagnetic astronomy. Every time you open a new field, I mean, we open X-ray astronomy and you find out the universe, or radio astronomy, you find out the universe isn't placid at all. It looks like a hellhole. I mean, all sorts of crazy stuff is going on. And so now here you have something which is completely different. It's done by masses that be accelerated, not charges that are accelerated. It gets through everything. And so you ought to find things that are new for that field. I mean, there are two pieces to that. You will look at old things you already know and know them better, and that's a supernova, for example, or even the neutron star, which binary. But there'll be hopefully some kinds of events or some kind of phenomena that you haven't thought of. I mean, that's generally been the case. But I can't tell you what they'll be. I mean, I'm hoping we'll find that the wormhole exists somewhere out there, and there you're looking into another galaxy. I mean, into another universe. Okay. I mean, and you know, I'll tell you something. So one of my colleagues sort of said he's already looked at the distribution of black holes. I mean, now we only have 5 of them, right? And I mean, 5 of these things. So you know, it can do some statistics, and it looks like there are too many of them in the southern hemisphere. Have you noticed that? No. Okay, now take a look. It's already getting a little embarrassing.
I see. Well, you actually answered my next question, which was what kind of unexpected sources.
I don't know all the
but if, from an instrumentalist point of view, I mean, obviously you had to work very hard to convince NSF to provide the $1 billion for this to happen. If you had all the money in the world, you know, $1 billion is not a lot by Silicon Valley standards these days. If you had all the money in the world, what would you do with it? What kind of an instrument would you build with it?
Instrument?
Yes. Oh, no, I did. Of course. Yeah. This was not such a general question.
Oh, my Lord. That's an interesting question and a very hard question. I mean, clearly, I have some interest in finding out what goes on at higher energies in high energy physics. I would love to see a linear collider being built. That looks like that has not directly to do with us, but it has indirectly to do with us. And we have an idea already which is going to cost billions, for this field, and that's I'll talk a little about that at the talk. In other words, a much larger version of LIGO. And I clearly think that the thing that you do in space, and that's going to happen. We're going to talk more about that later. People are spending their billions, at least in this field, that are thinking about the right things to do, I think. And it's really the fact that you have so many different phenomena at different frequencies. You know, I mean, the ground isn't the only place you want to do this. You want to do this. I mean, you want to do this in space. You want to do it. In fact, every one of the ideas that's being pushed, like the B modes, the pulsar timing, and the ELISA and the underground things, they're all complementary and very interesting. I don't know. I can't answer your question directly. Give me $1 billion or more than $1 billion. We're going to be asking for $1 billion at some point.
Right. But suppose even more than that.
Yeah. Well, yeah. That's. No. Let me tell you that $1 billion that we got already from the NSF was, here's something that everybody in the room ought to know. I want to not be able to say that. I said this very publicly other places. The NSF took an incredible gamble with us. And incredible in the sense of when you look now at the way they operate. Not the way they were operating back in the 80s, okay? Or mid-70s when this started. And the thing is that the gamble is deeper than you might even think.
How do you explain that?
Well, I can explain it. I can explain it with one very simple fact. We had a mole.
Who was that?
Richard Isaacson. Richard Isaacson was in the NSF. He was an expert in this field, had done his thesis with Misner. And he had the idea that the NSF, and this was as he came into the NSF in the middle 70s, and he had the idea that doing the Weber thing had just about settled as a null, okay? But he had the idea that this field, with a new technology that had come in, not just gravitational waves, but other things you could now test in general theory of relativity, which you couldn't have done 100 years before. Okay, when the theory first came out. I mean, I'll say a little about that in the talk too, but the thing is that now was an epoch where you could begin to actually challenge general relativity with experiment. He was thinking very deeply about that, and he thought that was exactly the right thing for NSF to do. And he convinced Marcel Barden, his boss, of that, who was a high energy guy, at Columbia, like nuclear physicist, and the two together made a team that just pushed through. And I'll give you very good examples of that. When an administrator in a government agency wants something, you arrange things properly, okay? You get the right reviewers, okay? You make sure that the people who are pleading the case know that they shouldn't do certain things and they should do other things. You guide the people who are doing the science. And that's what he did. He was he was the advocate for it in the NSF, but he was also the organizer of us silly people on the outside. So that was critical. But the other part was that he managed, despite that, to fight a battle which really was a very hard battle. We didn't have the technology ready, although we thought we did. And the theorists didn't have the sources in their heads right. I mean, the idea that, early days people were thinking of supernovae. And eventually became compact binaries, but only after a while. Okay? And so the thing is that we couldn't have gone out and advertised that we had guaranteed technology and guaranteed sources. And here we are asking for a big deal. That was the real gamble they took, yeah.
So perhaps the lesson from that is that we should encourage many of our students and postdocs to enter some offices in Washington and advocate for the science that we all want to be funded.
Very intelligent leadership in the government is absolutely needed. We don't have it right now, but that's enough.
I would like to open the floor for questions from the audience.
Erwin first.
Just one question about, you mentioned space, and I thought of Lisa, and I was wondering what the status and prospects are with Lisa.
Okay. I'll talk a little about that in my talk, but I'll tell you what I'll say. Lisa, as you know, was started as an American project, and then it became, back in the 70s, it's almost as old as LIGO. And what happened is that it was studied both by JPL and then by Goddard, and it became the last decadal survey gave it a high priority, but not the first priority. And that was always considered a negative point. It wasn't the very first thing everybody wanted to do. It was quite clear that astronomers didn't yet realize that there might be this really wonderful field that's coming. So W first was the thing that was the more important. And so that held things back. And then the budget travails that happened under Obama with the Republicans refusing to put money into the government at the time, really caused NASA to cancel their contribution to LISA. I don't know if you probably knew that, yeah. And that happened. And so what happened is that by that time the Europeans, especially the Germans, were pushing a lot of the technology in LISA, and they were deep collaborators. And so they decided they thought they could do it alone, which I think is a mistake, but that's just my own opinion. And they then kept the thing going. And this last mid-decadal survey that was done managed to get NASA, partly because of our success. It has very little to do with LISA's sources, but the fact that now there was finally gravitational waves detected. That was important to the administrators at NASA and other places as well in Congress. And so consequently, what happened is the mid-decadal survey made a recommendation that NASA should get back into it. And that happened. And now I can only tell you they're not fully into it, but there is negotiations going on with Europe about being the same kind of partner they were in the beginning. And the negotiations have to do with, should the Americans bring in an instrument, or this is a standard way that these collaborations get made. So right now the Americans are buying their way back, or trying to get their way back into it. The European councils have given it enough of a priority so that they want to launch a LISA-like mission in the mid-30s. And the people in Europe want to do it earlier than that. They want to do it in the end of the 20s. And that's the best I can tell you. There's been one more thing. I'll show you that, the data, if I have the time in the talk. They had a Pathfinder, the LISA Pathfinder, which was a huge success. And I'll show you that success. Okay.
There was this joke, I was on their review committee that actually Ray presented to a few years ago before the detection of the first gravitational wave source. And back then everyone thought it's a physics experiment because it's basically, it involves physics and it's a laboratory experiment. As soon as a source was detected, it became an astronomical observatory. Right. So that's the transition in the minds of people at NASA.
Well, it was more than that. It was more than that. You're right. I mean, the transition into astronomy, in fact, is now going on. And in fact, it makes things a great deal more complex in terms of trying to figure out how you plan the next stage. You involve the astronomers in it, and then they're very jealously keeping, they want money for their telescopes. And here's money needed for what was once a physics experiment, now turning itself into a slight bit of astronomy, a little bit of astronomy. So anyway, it's a very interesting time. Right now there's a transition taking place. But the thing that was really true, and I remember having this talk with the guy who was chief scientist at NASA during the Obama years, and he was the astronaut, John Grunfeld. That's right, Grunsfeld. I was at a meeting, and he was very blunt with me. He said, there was no chance that you would ever get a LISA mission until there had been a detection of a gravitational wave, because we didn't believe that they existed.
Really?
Yeah.
Well, he's not there anymore.
Well, no, exactly.
Anna?
Yeah, so, well, considering that you started working on this in the mid-70s, and the first detection wasn't until 2015, what was your initial reaction when you guys finally detected gravitational waves?
Yeah. That question of the 40 or 50 years of development, a lot of people ask that question. A lot of the press asks that a lot. I have one answer for you. That isn't exactly a direct answer. And that is that, of course, let me just say, I give you a little bit of a direct answer. We were skeptical. And that's not because of that, it looked too good. That was one of the problems. You'll see a picture of that again in my talk, but, and you've seen it before, but anyway, I want to point out some things about it. But we were skeptical, and then we started making up complicated reasons why we should be even more skeptical. And, but then eventually we bought it. It took a while. But the thing is, though, I want to tell you about the 40 years, okay? Because that people make a huge fuss about that. And it turns out those 40 years were wonderful. They were an absolute pleasure. Why? Because it's fun to work, at least for some of us, it's fun to work on technical things. And you make a circuit and it works and you get a tremendous pleasure out of it. And you go to your buddy next door to you and say, hey, let's go out for a beer. Let's celebrate. Okay. And you have, that's why you're in science. At least so many of us are. We gotta get a big kick out of the fact that developing the technology and making progress is the thing that sort of keeps you going day by day. And that you're working with convivial people who feel the same way. So it's not an endless thing of, oh my God, we haven't detected a gravitational wave yet. That's not the way it goes. And a lot of people have that misconception. I'm sure you don't, but that's what they make out of that 40 years. They say, oh, how did you live through that?
Well, as it turns out, the 40 years were a theoretical prediction because there is actually a biblical story about 40 years before getting to the promised land. But we need to move on. Thank you very much.
You're quite welcome. Thank you.